At the edge of the solar system, the Sun is just another star. From here, 3.7 billion miles away, our Sun looks like the brightest point in a sky full of stars. Not a blazing disk, just a distant spark. And in that twilight, we found something nobody expected. Fields of ice blades, razor sharp, made of frozen methane, some as tall as skyscrapers, rising hundreds of feet from a surface that was supposed to be dead. We thought Pluto would be boring, a frozen rock at the solar system's edge, a relic, a corpse. We were spectacularly wrong. And beyond Pluto, beyond the edge of sunlight, something massive might be hiding, shepherding the orbits of worlds we've only just discovered. Worlds with names like Far Out and Far Out, because we literally ran out of better ideas. This is the Twilight Zone, where sunlight fades, where mysteries multiply, and where we're only beginning to understand what's out there. February 18th, 1930. Clyde Tombaugh, a 23-year-old assistant at Lowell Observatory in Arizona, was comparing photographic plates of the night sky when he noticed something moving, a faint dot shifting position over several nights. He'd found what astronomers had been searching for: Planet X, the 9th planet, the final member of our solar system's family. They named it Pluto, after the Roman god of the underworld, fitting for a world so far from the sun's warmth. For 76 years, Pluto sat comfortably in textbooks, the 9th planet. Small, yes. Weird orbit, sure. Highly elliptical, tilted 17 degrees from the plane where all the other planets orbit. But still a planet. Then came the discoveries. 1992. Astronomers discovered the first Kuiper Belt object beyond Pluto, a chunk of ice and rock about 150 miles across, orbiting in the region we'd assumed was empty. Then another, and another. Hundreds, thousands. Pluto wasn't alone out there. It was part of a population, a swarm of icy worlds circling the sun in a vast donut-shaped region called the Kuiper Belt. In 2005, astronomers discovered Eris, a Kuiper Belt object, larger and more massive than Pluto, orbiting even farther out. If Pluto was a planet, Eris had to be too, and maybe dozens more. The International Astronomical Union faced a choice: redefine what planet means, or admit Pluto never quite fit the definition. August 24th, 2006. The IAU voted. Pluto was reclassified as a dwarf planet. The 9th planet was demoted. The solar system had 8 planets again. And everyone assumed Pluto would fade into obscurity, a historical footnote, a demotion that ended its story. But 7 months before that vote, NASA had already launched New Horizons, a spacecraft the size of a grand piano, carrying the fastest rocket ever built, hurtling toward Pluto at 36,000 miles per hour. It would take 9.5 years to get there, and when it arrived, it would reveal that Pluto's story was just beginning. July 14th, 2015, 7:49 a.m. Eastern Time. New Horizons screened past Pluto at 31,000 miles per hour, passing just 7,800 miles above the surface. Too fast to orbit, too fast to slow down. This was a flyby, one shot, years in the making, over in minutes. The spacecraft's cameras had been taking photos for months as it approached. Low resolution at first, blurry, then clearer, sharper. And as the images resolved,
mission control at Johns Hopkins Applied Physics Laboratory went silent. They were looking at a heart, not metaphorical, not poetic, an actual heart-shaped region on Pluto's surface, bright white against darker terrain. 1,600 kilometers across, a feature so prominent you could see it from millions of miles away. They named it Tombor Regio, after Clyde Tombor, who'd found Pluto 85 years earlier. And it was young. The western lobe of the heart, Sputnik Planitia, was a glacier, smooth, no craters, geologically young, no more than 10 million years old. On a world 4.5 billion years old, that's yesterday. Which meant one impossible thing. Pluto was geologically active, present tense, not a dead relic, an active world. The glacier wasn't static, it was moving, convecting, like lava lamps or boiling water, but in slow motion over millennia. Nitrogen, methane, and carbon monoxide ices, frozen at -229 degrees Celsius, were soft enough to flow. Warm material from below rose to the surface, cooled, and sank back down, creating polygonal cells 10 to 40 kilometers across. Pluto had weather, tectonics, active geology. Nobody expected this.
And then there were the mountains. Water ice mountains, frozen as hard as rock at Pluto's temperature, rising 11,000 feet above the plains. Steep-sided, angular, like the Rockies, but made of ice. Some appeared to be floating, icebergs drifting across Sputnik Planitia's frozen sea. But the strangest feature wasn't the heart, it was the blades. Near Pluto's equator, in a region called Tartarus Dorsa, the surface looked like a field of knives. Jagged ridges of ice, hundreds of feet tall, aligned roughly north-south. Blade-like structures stretching for miles. Scientists stared at the images and asked, what could create this? It took years to figure out. The blades are made almost entirely of methane ice. They form through a process called sublimation erosion. Methane freezing out of Pluto's thin atmosphere at high altitudes, then slowly evaporating away as climate conditions change over millions of years. What remains are these dramatic crests and sharp divides. Penitentes, scientists call them, similar to spiky snow formations found in high-altitude regions on Earth, but on Pluto, they're as tall as New York City skyscrapers. The blades tell us something profound. Pluto's climate changes over time, not year to year, over millions of years. Long cycles driven by its eccentric 248-year orbit around the Sun. Sometimes Pluto is slightly warmer. The methane sublimates faster. The blades grow. Sometimes it's colder. The methane freezes. The blades erode. Pluto has seasons measured in eons. And an atmosphere. Thin, just 10 microbars at the surface, 100,000 times thinner than Earth's. But it's there. Nitrogen, with traces of methane and carbon monoxide. New Horizons measured up to 20 distinct haze layers extending 1,000 miles from the surface. Pressure waves driven by airflow over Pluto's mountains create these layers, like ripples in water. Pluto has wind, clouds, weather. And it's not alone. Charon, Pluto's largest moon, is half Pluto's diameter. They orbit each other, a binary system. Two worlds locked in gravitational embrace, forever facing each other. Charon is scarred. Its north pole is covered in dark reddish material, organic molecules called tholins, created when methane escaping from Pluto's atmosphere freezes on Charon's surface,
and is irradiated by ultraviolet light. Charon has a violent history. A canyon system wraps around its equator, Argo Chasma, deeper than the Grand Canyon. Evidence of a subsurface ocean that froze and expanded, cracking the crust like ice in a bottle.
And Pluto doesn't just have Charon. It has 4 smaller moons: Styx, Nix, Kerberos, and Hydra. These tiny satellites, ranging from 10 to 90 kilometers across, orbit in a complex dance. They're in orbital resonances with Charon, their periods locked in precise mathematical ratios. Nix orbits in a 3:2 resonance with Charon. Styx is in a 3:1 resonance. Hydra, 6:1. The gravitational choreography is so precise that some of these moons tumble chaotically, unable to settle into stable rotation. They spin like wobbly footballs, their orientation unpredictable over time. The Pluto system isn't simple. It's intricate, dynamic, a miniature solar system within the solar system. Pluto was supposed to be simple, frozen, dead. Instead, we found active geology, convecting glaciers, mountains of ice, blade fields as tall as skyscrapers, a dynamic atmosphere, evidence of a subsurface ocean, maybe even today. A binary companion with its own violent history. 4 smaller moons in orbital resonance. The demotion had nothing to do with Pluto's complexity. It's one of the most geologically diverse worlds in the solar system. But Pluto raised a question nobody had asked seriously before. If this far from the Sun, a dwarf planet can be this active, what else is out there?
The Kuiper Belt starts where Neptune's orbit ends, about 30 astronomical units from the Sun. 1 AU is Earth's distance from the Sun, 93 million miles. The belt extends out to roughly 50 astronomical units. A vast donut of debris, leftover material from the solar system's formation 4.5 billion years ago. Chunks of rock and ice that never coalesced into planets. We didn't know it existed until 1992. 1992. David Jewett and Jane Liu, using the University of Hawaii's 2.2-meter telescope, discovered 1992 QB1, the first confirmed Kuiper Belt object. It was revolutionary, proof that the solar system didn't end at Pluto. There was structure out there, a population. By 2000, we'd found 100 Kuiper Belt objects. By 2010, 1,000. Today, over 3,000 confirmed, with estimates suggesting 100,000 objects larger than 100 kilometers across, still waiting to be discovered. January 1st, 2019. 3.5 years after passing Pluto, New Horizons flew past Arakoth, a Kuiper Belt object 4 billion miles from Earth. Arakoth looked like a reddish snowman, 2 lobes gently merged together. The most primitive object ever visited by a spacecraft. A pristine relic from the solar system's birth, kept in deep freeze for billions of years. Its smooth surface, lack of craters, and bi-lobed shape told scientists it formed gently. No violent collisions, just 2 objects drifting together in the early solar system and sticking. Arakoth is what planets are made from, the building blocks frozen in time. But some Kuiper Belt objects don't follow the pattern. Most orbit in a relatively flat disk, like the planets. But others, scattered disk objects, have wildly elongated, tilted orbits. They swing out to hundreds of AU, far beyond the main belt. These objects were scattered by gravitational interactions with Neptune billions of years ago. flung outward like stones from a slingshot. And then there are the truly strange ones. Sedna, discovered in 2003. A world about 3/4 Pluto's size with a bizarre orbit. Perihelion at 76 astronomical units. Aphelion at 937 astronomical units. It takes 11,400 years to complete one orbit. Sedna never comes close to Neptune. Its orbit is too distant, too circular to have been scattered by the ice giant. So how did it get there? Something massive must have pulled it outward. But what? 2012, VP113, nicknamed Biden. Perihelion, 80 AU. 2015, TG387, nicknamed the Goblin. Perihelion, 65 AU. And in 2025, Ammonite, officially 2023, KQ14, with a perihelion at 66 AU. And here's where it gets strange. These extreme objects, these distant, detached trans-Neptunian objects, don't orbit randomly. Their orbits cluster. They point in the same direction. Their perihelions align. The probability of this happening by chance? About 0.007%. 1 in 15,000. Something is shepherding them. Something massive. Something we haven't found. But we have a hypothesis.
January 20th, 2016. Caltech astronomers Konstantin Batygin and Mike Brown published a paper in the Astronomical Journal that revived an old idea with new evidence. Planet 9. A hypothetical world 5 to 10 times Earth's mass, orbiting 200 to 800 astronomical units from the Sun, 10 to 40 times farther than Neptune. The same Mike Brown who'd discovered Eris and helped get Pluto demoted. Now he was proposing a replacement, a real 9th planet hiding in the dark. The evidence. 6 Kuiper Belt objects with extreme orbits, all with similar orientations. Their orbits clustered in a way that couldn't be explained by Neptune's gravity alone. Batygin and Brown ran simulations, thousands of them, testing different scenarios. Only one explained the clustering. A massive planet on a distant, elongated orbit, anti-aligned with the Kuiper Belt objects, its perihelion opposite theirs. Its gravity gently tugging these distant worlds into alignment over billions of years. Planet 9 wouldn't orbit like the other planets. According to their models, its orbit would be semi-major axis, 400 to 800 astronomical units, average distance from Sun. Perihelion, 200 to 350 astronomical units, closest approach. Aphelion, 600 to 1,200 astronomical units, farthest point. Eccentricity, 0.2 to 0.5, highly elliptical. Inclination, 15 to 25 degrees, tilted from planetary plane. Orbital period, 10,000 to 20,000 years. Mass, 5 to 10 Earth masses. Likely a mini Neptune, gaseous with an icy core. This orbital configuration acts like a cosmic lever. Planet 9's gravity doesn't scatter these objects. It organizes them, shepherds them into stable, clustered orbits over billions of years. Since 2016, the evidence has grown and gotten more complicated. April 2024. Batygin and Brown published new research showing that Planet 9 could also explain a population of low-inclination trans-Neptunian objects that cross Neptune's orbit. These objects shouldn't be stable. Neptune should have ejected them long ago. But if Planet 9 exists, its gravity could protect them. The hypothesis now explains 3 independent populations: the extreme, clustered, detached objects,
high perihelion objects with similar orbital tilts, low inclination objects that survive near Neptune. That's strong evidence, multiple independent observations pointing to the same explanation. September 2025. New analysis of Kuiper Belt orbital planes suggested something even stranger. The collective warping of orbits indicated a planet might exist closer than originally thought. 100 to 200 astronomical units instead of 400 to 800 astronomical units. If true, Planet 9 could be 25 to 450 times Pluto's mass. Smaller and closer than predicted, but still massive enough to shepherd distant orbits. Or it could be multiple planets, or a scattered population we haven't detected yet. The data allows multiple interpretations.
And help is coming. The Vera C. Rubin Observatory in Chile, with the world's largest digital camera, 3.2 gigapixels, began scientific operations in late 2025. It will survey the entire visible sky every few nights, going deeper than any previous survey. Konstantin Batygin said, "It might just find Planet 9 directly. At the very least, it will find a ton more Kuiper Belt objects. Even if it doesn't discover a single new object, it will be enough to confirm the Planet 9 hypothesis, because it will test all of the statistics. Within 5 years, we'll know. Either Rubin finds Planet 9 directly, or it discovers enough new objects to prove or disprove the clustering statistically." But not everyone agrees. Some scientists argue the clustering is observational bias. We discover objects where we look most carefully, creating artificial patterns. Others propose alternative explanations. A second Kuiper Belt farther out, with collective gravity mimicking a planet. A primordial black hole the size of a grapefruit, too small to see but massive enough to warp orbits. Interactions with passing stars when the Sun was younger, nudging objects outward. Modified gravity theories that don't require a planet at all. The 2025 discovery of Ammonite complicated things further. Its orbit doesn't quite fit Planet 9 predictions. It fills a gap where no objects should be if Planet 9 exists as originally described. But Batygin and Brown remain confident. In their 2024 update, they stated, "Despite recent discussions, statistical evidence for clustering in the outer solar system remains strong, and a massive planet on a distant, inclined, eccentric orbit remains the simplest hypothesis that can account for all three populations of trans-Neptunian objects." The hunt continues. Somewhere between 200 and 800 astronomical units from the Sun, a world 5 to 10 times Earth's mass might be orbiting in the dark. Too faint to see directly, too distant to perturb planets, but massive enough to shepherd the orbits of worlds at the solar system's edge. And within 5 years, we'll know if it's real. January 15th, 2018. Scott Shepard, David Tholen, and Chad Trujillo were using the Subaru telescope in Hawaii, searching for Planet 9. They found something else. A faint dot, magnitude 25. So dim, only the largest telescopes on Earth could see it. When they calculated its distance, they didn't believe it at first. 132 astronomical units from the Sun, 12 billion miles, 4 times farther than Pluto. They called it FarFarOut because they'd already used FarOut for the previous record holder at 124 AU and, well, this one was even farther. Officially designated 2018 AG37, FarFarOut is the most distant observable object currently known in the solar system. But here's the remarkable part. FarFarOut doesn't stay at 132 AU. its orbit is wildly elongated. At aphelion, its farthest point, it reaches 175 astronomical units. At perihelion, it plunges inward to just 27 astronomical units. It crosses Neptune's orbit. Every 1,000 years, FarFarOut swings through the outer solar system, passing close to Neptune. And every time, Neptune's gravity tugs at it, warping its trajectory slightly. FarFarOut was likely thrown into this extreme orbit by Neptune itself, flung outward billions of years ago after wandering too close to the ice giant. Based on its faintness and distance, scientists estimate FarFarOut is about 400 kilometers across, just barely large enough to be classified as a dwarf planet. And it's alone, out there in the dark, where the sun is just a bright star. FarFarOut tumbles through space on a journey that takes a millennium. By the time it completes one more orbit, the year will be 3025. FarFarOut is not alone in being extreme. FarOut, 2018 VG18, 124 astronomical units, pink from irradiated methane ice. The Goblin, 2015 TG387, never comes closer than 65 astronomical units. Sedna orbits out to 937 astronomical units, taking 11,400 years per orbit. These are the objects that might reveal Planet 9. If it exists, its gravity should be sculpting their orbits in predictable ways. But FarFarOut can't help us find Planet 9. Its orbit crosses Neptune's, which means Neptune's gravity dominates its motion. Any signal from a distant planet is drowned out by Neptune's much stronger pull. To find Planet 9, we need objects that never come close to Neptune. Objects like Sedna. Objects whose orbits are shaped only by whatever lurks in the outer dark. And we need more of them.
But there's one more boundary, one more edge, the Heliopause. The place where the sun's influence finally ends, where the solar wind, charged particles streaming from the sun at 1,000,000 miles per hour, slams into the interstellar medium, the gas and plasma between stars. Two forces, equal pressure, a standoff. The sun creates a bubble around itself, the heliosphere, shaped like a bullet, with a nose pointing in the direction the sun travels through the galaxy and a tail stretching behind. At about 90 astronomical units, the solar wind hits the termination shock, the point where it slows from supersonic to subsonic speeds. Then comes the heliosheath, a turbulent region where solar wind and interstellar plasma mix and jostle. And finally, at about 120 astronomical units, the Heliopause, the true edge, where the sun's bubble ends and interstellar space begins.
August 25, 2012. Voyager 1 crossed the Heliopause at 122 astronomical units from the Sun, becoming the first human-made object to enter interstellar space. Scientists weren't sure at first. Voyager 1's plasma instrument had failed in 1980. They had to rely on particle detectors and magnetic field measurements. The breakthrough came in April 2013, when a solar storm sent plasma waves rippling through space. Voyager 1's plasma wave subsystem detected oscillations, ringing in the plasma, that allowed scientists to calculate density. It matched interstellar space. Voyager 1 had crossed over. November 5th, 2018. Voyager 2 crossed the Heliopause at 119 astronomical units, closer than Voyager 1 because the heliosphere breathes. It expands and contracts with the sun's 11-year solar cycle, like lungs filling and emptying. Voyager 2's plasma instrument was still working. For the first time, scientists had direct measurements of both sides of the boundary. What they found was strange.
The Heliopause isn't a wall, it's a transition zone.
But both spacecraft measured temperatures of 30,000 to 50,000 Kelvin, 54,000 to 90,000 degrees Fahrenheit. A wall of fire. Superheated plasma where two winds collide. But here's the strange part. The spacecraft survived. The plasma is so sparse, just a few particles per cubic inch, that even though individual particles have extreme energy, there aren't enough of them to transfer meaningful heat. The Voyagers sailed through unscathed. It's a wall made of almost nothing, but it's real. And the magnetic fields didn't change direction. Scientists expected the field to rotate as Voyager crossed from solar to interstellar regions. Instead, it stayed aligned, almost as if the sun's magnetic field and the interstellar field were connected. Voyager 1 saw it. Voyager 2 confirmed it. The boundary is more complex than anyone thought. There might be magnetic flux tubes, highways for particles to flow between the heliosphere and interstellar space.
New Horizons is next. Currently 59 astronomical units from the Sun and traveling outward at 3.1 astronomical units per year, New Horizons should reach the termination shock by the late 2020s and cross the Heliopause around 2040, if its plutonium power source holds out. New Horizons has instruments Voyager didn't. Modern sensors to measure pickup ions, interstellar particles that get swept up by the solar wind. These particles dominate the pressure in the outer heliosphere and play a central role in holding the boundary against interstellar wind. When New Horizons crosses, it will be the third spacecraft to enter interstellar space. And with better instruments, it might finally explain how the heliosphere withstands the pressure from outside. Right now, Voyager 1 is 165 astronomical units from the Sun. Voyager 2 is 137 astronomical units. New Horizons is 59 astronomical units. 3 spacecraft, 3 trajectories, 3 different crossing points, measuring the boundary in different places and times. Together, they're mapping the edge, the place where the sun's light fades and interstellar space begins. The Heliopause is the true edge of sunlight. Beyond it, the sun is just another star. The edge of sunlight isn't where we thought it was. For centuries, we imagined the solar system as 8 planets orbiting the sun in an orderly procession. Beyond Neptune, emptiness, a void, the end. We were wrong. Beyond Neptune lies a population, thousands of worlds, dwarf planets, ice chunks, rubble piles, circling the sun in a vast belt we only discovered 3 decades ago. And beyond the belt, more objects, scattered, distant, some at distances so extreme they take thousands of years to orbit once. And beyond even those, the Heliopause, the wall of fire where the sun's wind meets the interstellar medium at 120 astronomical units. We thought Pluto would be boring. We thought distance from the sun meant death, inactivity, frozen silence. Instead, we found ice blades as tall as skyscrapers, convecting glaciers, mountains, weather, a binary companion, orbital resonances, active geology on a world 3.7 billion miles from the sun, where sunlight is 1,600 times weaker than on Earth. Pluto is thriving, not despite the distance, because of it. Because out here, things behave differently.
Methane is rock. Nitrogen flows like water. Time moves in million-year cycles. New Horizons is still going. It's 5.5 billion miles from Earth now, traveling at 30,800 miles per hour. Every year it covers 300 million miles. By the late 2020s, it will reach the termination shock. By 2040, the Heliopause. If its power holds out, New Horizons could keep transmitting into the 2040s or beyond. By then, it will be in interstellar space, measuring the galaxy between stars. And still, it will only have scratched the surface of what's out there.
The Vera Rubin Observatory is watching, surveying, finding hundreds of new Kuiper Belt objects every year. Maybe it will find Planet 9 directly, a faint dot moving against the stars, revealing a world larger than Earth, hiding in the outer dark. Maybe it will find so many more objects that the statistics become undeniable, confirming Planet 9 exists even if we never see it directly. Or maybe it will show us something we didn't expect. Another population, another structure, another mystery. 10 years ago, Pluto was a pixelated blur. The Kuiper Belt was a hypothesis. Planet 9 didn't exist in any serious discussion. The Heliopause was theoretical. Today, we've visited Pluto and Arakoth, found thousands of Kuiper Belt objects, proposed a 9th planet, crossed the Heliopause 3 times with 3 different spacecraft. The outer solar system is no longer empty. It's a frontier, a laboratory, a place where physics operates at extremes and worlds defy expectations. At the edge of sunlight, we're only beginning to see. At the edge of the solar system, the sun is just another star, a bright point in a sky full of stars. From here, Earth is invisible. Neptune is a distant blue dot. The inner solar system, the planets we grew up learning about, is compressed into a tiny region barely distinguishable. This is the twilight zone. Not dark, not bright. Perpetual dusk. We thought the story of the solar system was simple. 4 rocky planets, 4 gas giants, maybe some asteroids and comets. The end. But the solar system doesn't end at Neptune. It extends for thousands of astronomical units, billions of miles, to regions where gravity is so weak that passing stars can perturb orbits, where the sun's light is so faint that ice behaves like continents and methane sublimates over millions of years. And somewhere out there, maybe, a 9th planet orbits, 5 to 10 times Earth's mass, tilted, elongated, shepherding the orbits of worlds we can barely see.
FarFarOut is out there right now. 132 astronomical units from the sun, tumbling through space at the solar system's edge. It won't complete its next orbit for 1,000 years. When it returns to perihelion in the year 3025, humanity might have spread across the solar system. Or we might be gone. FarFarOut doesn't care. It will keep orbiting regardless. These are the worlds that exist at the edge of sunlight. Not planets, not asteroids. Something in between. Oddballs. Survivors. Witnesses to the solar system's formation who've stayed frozen in time while the inner planets evolved. And beyond them, the Heliopause? The wall of fire where the sun's influence finally ends. Voyager 1 and 2 have crossed it. They're in interstellar space now, measuring the galaxy between stars. New Horizons will join them in 20 years. 3 spacecraft, 3 messengers, carrying humanity's story into the dark. The edge of sunlight is 120 astronomical units. But the edge of human reach? That's still being written. This is Cosmic Canvas, where we explore the twilight zone at the edge of sunlight. Until next time, look beyond the obvious. The most interesting stories hide in the shadows, where sunlight fades and mysteries multiply. The 9th planet might be out there. The Heliopause is real. And somewhere, right now, New Horizons is still flying. The edge is farther than we thought, and we're still exploring.